So let's keep going with the design. All right, let's create the center shaft now. Let's see here. Okay, yeah. So this should be 6. There we go. I want to check something. I gotta make sure. Uh, this is 5. Yep, nice. Okay. So this is 6. We can create a sketch. Capture position. -6. -6. Join, not join new body. Now we can get rid of the. No, get rid of this and this. This should be 4. Yep. Okay. Create component. -4. Oh, wait, why did I do that? Okay, let's delete this sketch here. Create new sketch. -4. Okay, why is it doing that? I'm actually quite confused. Oh, because this is in the way. Okay. Let's delete this. We don't need this. Let's go here and edit this one here. Okay, there we go. -4. New body. Here is should be 8. Create sketch. Extrude -8. New body. And create sketch. Get rid of the sketch. -4. New body. And this should also be 6. -6. New body. Okay. Nice. Alright. Perfect. Now we have this. Wait. Get rid of this. So we have the shafts here. Okay, how do we go about... Okay, let's just... Sure, 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. Sure, 0.5. Okay, now everything should in theory line up properly. There we go. Nice. Okay. So now let's do something. We need to measure the hex of a 4.8. Okay. So the hex of a M2.5 is a 4.8 millimeter. So let's just go ahead and create sketch here. We can just do that all the way through. Let's see, where is it? Oh, no. Before we do that, let's actually do this. Create sketch. We need to make this 15 for the ball bearing. Okay, so create sketch 15. Create sketch 15. Get rid of this. Extrude down. Perfect. Okay, now once we bring everything back, we should be able to go to create sketch and a polygon is scribed. What did I say it was? 4.8. Alright, perfect. 4.8. 4.8 divided by 2 is 2.4. Okay, We can extrude this all the way through. And we also need to do create sketch and do two, maybe like around right here, maybe? We need to do it M3, so 2.9. Yeah, this looks like it would work. You cut this all the way through. And let's bring in the motor. It's okay, so the motor is mounted here. Bring back all the bodies. I think adding a chamfer to each of these points here will be very optimal for the 3D printability of everything. Let's go here. Okay, let's not worry about this right now. Let's worry about the more important stuff. Okay, so this. And where's the motor? Motor. Okay, so the motor. Okay, let me think. The motor. It can be mounted like this, right? The output shaft and the motor should stay together. The only thing moving should be this. Yeah, okay, perfect. So this is actually, let's see here, what is this? Diameter 25. Okay, let's get rid of this. Let's do a create sketch here. Let's go out 26. Let's just go out 25. No, let's go 26. And then, so that's where it mounts. Okay, wait, let me bring in. Okay, so we need a way for it to mount. I want to somehow keep it as close to this as possible. Okay, let's get rid of this, get rid of this. This is a 6. Okay, no. Okay, so if it's a 6, basically this entire thing can go up a little bit. What I'm trying to think is how can we mount the motor? Because we know the motor has a 16 and 19. 19, and a closest would be the 16. Just a little bit. Not the most ideal because everything's so close together. This is 6. What I could do is perhaps... Okay, the one sure way to do this is scoot the motor up a little bit, but I don't know if I want to do that. Because if we do that, then... Or we can use a different ball bearing. Let's see if I have one laying around on my table somewhere. I can't seem to find it, but it's a 6x10, I believe. And this should be smaller. The bolt should be smaller than it. Yeah, it's smaller than 6, so it'll definitely fit through that. I feel like this is pretty important for strength, though. So if we... Yeah, I really don't see a way we can mount this straight like this, so what I think I'm going to have to do is actually move this part up 3 millimeters. Which is gonna, unfortunately, make everything slightly bigger by 3 millimeters, which is not too big of a deal, I guess. Okay. Now, what we can do is make this go down 1 millimeter, or yeah, 1 millimeter. So we'll still have 5 millimeters. That's plenty of space here. Okay, let me think here. And then maybe we can go down to another millimeter. Because this will still have 4, which is plenty enough. And then, okay, yeah, this is good, this is good. And then what we can do here is actually move this down 1 more millimeter. We don't need 3, we only need 2 between them. And then we can move this entire thing up. This middle section. Okay, how do we do that? Let me think. Okay, let's move this out of the way for now. Let's do a create sketch. Okay, let's get rid of all these other sketches. '21, and this can go all the way to like, say what, like 6 should be good. Yeah, 6 should be good. And we can do 1. Now this will leave us with 1 millimeter clearance right here. And then we can do... Okay, now if we mount the motor, it only has 1 millimeter clearance. So that's not good enough. So let's actually... We can either make this entire thing thicker, or we can just make that shaft part thicker. What should we do? We should definitely make the shaft thicker. So let's go with that for now. So there was 25 total, so we can do 35. Let's do a 25. 25. Let's do 26. Let's do 2. Bring this back. Now it should line up properly. There we go. Get rid of this for now. Okay, and now we can do a 16, 19. Let's do 45 degrees too, because the wire is at 45. And this wire, let's see here, this is a 16. No, not 16, what am I talking about? This is a M3, so we do 2.8. And okay, this right here will be a 2.8 also. Now we can just take, not this, mirror across this. Okay. Mirror this across this. Click OK. Perfect. There should be 8 because 2 plus this. What happened here? This is not ideal. So we actually hit this? Question mark? Okay, we definitely do not want any of this happening here. Okay, we need to change this somehow. Let's see here. Okay, let's go. Okay, so from here to here is 3. Yeah, let's go back to the extrude and just do -3. And what we need to do here is add. This can go away for now. Okay, let's see here. We need to add a 5.5. 5. We could make it a little bit thicker, which will probably be pretty, which I'll probably do actually, because I do feel that it could be, it would be a good idea to do it because it'll be a little bit stronger to mount the motor. Let's do this. That did not work. Sketch, there we go. Okay, that worked. Now we have 5.5, so we should be able to mount everything in. Okay, let's actually do, just do 6. So I don't have to worry about it not fitting or anything. Definitely use countersunk here. Add a chamfer of 2. That should be plenty enough for it. Let's go 2 here. This will unfortunately increase the length, the width, by another 2 millimeters, but it definitely is necessary for everything to work out properly. Okay. Now that we have this shaft going out and we have the input shaft and everything, let's bring back all the parts. Let's get rid of this for now. 26. We will need to extrude this out 1 to add clearance. And then what we can do is, so we have to extrude this side out 1 too. We need to add encoder mounts to here. Let's see if we can somehow add an encoder. Let's see, how do we do this? The encoder's 23 by 23, I believe, so what we can do is sketch 23 by 23. This could go down -2. And since it was 7, so we still have over 4, yeah, we have 5. Let's go down 1 here. Okay. This won't work. We won't have enough space to mount the encoder. This is sad. Okay. So this will add more space. Let's actually... Okay, let's see here. We need to mount the encoder somehow. But I really want to do it here. Okay, how about let's do this. Okay, okay, I think I have an idea. For now, let's just do this part. $6.5, okay. Let's do a new body here, and then we can join this like this. Okay, let's make it as slim as possible. Okay, so from here to here, we only want 4, so 6.5 minus 4, what is that? 2.2? 2.5? I mean, oh my god. Okay, now, wait, am I tripping? What did I just... Okay, it's fine. We need a 0.5 there, actually, because we extruded this down 0.5. Forgot about that to add clearance. Okay, so this is the... Wait, this to here is 3. Get rid of this. And... Okay, sketch. Okay. No, I don't want to do this. I want to... Okay, let me think. So now I have this. Okay, let's do a create sketch here and do a... Let me think. 8, 7, 8 maybe? Extrude this out 5. Go here, create sketch. Make this at 2. 2.2. Just do 2 for now. Negative 2.5. This will be where the magnet sits. Okay, so in this case, right now we have 3 millimeters of space, so we can make this go up. Low-key want to make everything symmetrical. What is this? Okay, so this is 35. Okay, let's go 35 here too then. And we can extrude this up 3 for now. I think that's what I did on the other side. Oh, wait, no. How much should I extrude this up? Okay, no matter. We'll worry about that later. Okay, so now what we can do is we'll add from here to here 6, so we can do 5. Okay, that's good. That's good. This is perfect. Negative 5. Create sketch. We want to do a 23 by 23 or a 24 by 24. Negative 3. We could just use an M2 here and a... Yeah, we should definitely use the M2, 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 M2 instead of M3. M3 is 4 millimeters, so it might be too thick. I don't know though. Let's do this so it's symmetrical for now, but we can definitely get rid of that later if we need to. Okay, so we have 1 millimeter of space here. Definitely need to add a 5.5. Okay, this is quite tight. Actually, it'll be fine. Okay, we will go down 1, and we will go up 4. Now we can do a chamfer here. Okay, this is perfect. We need to check we need to check my old design here. For the here to here, it was what? Wait a second, this seems wrong. 16. What's a 16? 16. Okay, it's 16 then. Create sketch. 16 by 16. Okay, there we go. Here we do. Okay, should we either do M3 or M4? Let's do it. Let's do M3 here. So we do 2.8. 2.8. We don't even have a mirror line. Okay. Let's go add a parameter here of M2I 2.8. M2 heated insert. M2I. It's a 3x3, so it needs to sink down -3 at the very least. So this won't work because it will sink into the ball bearing. So we need to somehow move this up 3. And then we can go... Okay, how do we do this? Let's go back to this. No, no, no. Okay, let's just delete this extrude. Delete this. And here's 5, so we can go down 1. We only need 4. Okay, this is good now. This will work. This will work. No. Okay, there we go. M2I. Okay, now we have a place to mount everything we need. And we should probably do something like, let's see here, only keep the necessary parts, so we need to do a something like this, mirror across this, and then we do something like this, and then now we can do that on all parts. Okay, everything other than this can go negative 4 maybe? This is 5. Just a negative 3. Negative 1. Okay, this is better. Okay, let's just keep it like this for now. This will work. Let's go here and paste new, where is it? Flip this 180 and scoot this. I'll put it here for now. Let's measure this to here is 1.6. 1.6, okay. And this to this is 3.4. 3.4, so let's do 4 millimeters. That will give us plenty of room. This is 6. We need 4, so we need to bring this up 2. This could easily be changed later if we need to. Let's just bring this so it's here. Okay, now it should be sitting flush. And it's not for some reason, because apparently I did something wrong. Okay, let's see. This is 3. Oh, okay, that's why. Alright, it's flush enough, right? Actually miscalculated this quite a bit. 2.5. Okay, this should be fine now. Probably need a little bit more clearance. We can add that later. Okay. So what we can do is actually make this go up by, can we go 2? We can, okay. This is 7 millimeters. Here will also need to be 7 millimeters. And now, finally, we can do a, let's see here, sketch. wait, this is wrong. It needs to be down here. Okay, nice, okay. -7. Wait a minute, this shouldn't connect, right? Let me think. No, no, it's okay if it connects, I think. Right? I think so, okay. Let's do a project of this. -7. Okay, so this is a very, very compact design. This is 48. Add in the motor. 64. That is crazy. Compared to this design, it's gonna weigh way less. 81. Okay, so that's like 20 millimeters. That's crazy. Okay, and it has thicker arms here too, which is good. Okay, now I just need to make sure I did everything right, because something is not adding up right now. Okay, yes, this is a problem. This... Oh my goodness, okay, these are not secured. This and this is not secured in here. It needs to be somehow bolted down. We could have some bolting system here, but I really feel like we need some other type of... Is there a way we can mount it in here somehow? I don't think... Okay, unless we get rid of one. Okay, yeah, this would work. Right? Trying to think here. So if we did two of them not being... Actually, we don't need to worry about one here. We just need to worry about one. So if we just replace one with a M3 bolt going through instead of that, 34. I think this would work. And we have a bolt running through the entire thing. So we just have a bolt running through here and then have a lot of bolts here that would keep this from going anywhere. That would be secured. But okay, there's not a... I'm trying to think. How can we secure this piece now? We could do a lid type system, but... Or we can do... Actually, you know what? I think I have an idea. Okay, yes, this would work. This would work. Okay, so. If we can make it this. If we can just clamp the ball bearing on both sides. That would make it work. I'm trying to think, how can we do that? How can we clamp it on? -1. So we're gonna have. There's only 1 millimeter of space though. Is that enough? That's a good question. I think we did 52 here, right? And then why is it doing that? Okay, let's do 50 like this. Okay, we can just do something like this. I think this should prevent everything from coming apart, right? I'm trying to think. I think this should be good. Yeah, let's go ahead and do this and see if it's good. I think it'll be fine. Not sure though. One. Join. I actually haven't seen anybody done this before. I feel like this is a pretty smart design. Okay, and then let's just... Or another thing we can do is... Actually, no, that won't do any good. I just need to prevent this from sliding up and down, which I think this little ledge with a ball bearing in here should prevent it, right? I'm trying to... Okay, let's just go ahead and continue. Okay, yeah, that should be fine. Why don't I just do this? $45. This actually looks pretty neat. Okay, let's check the overall 64. It's still relatively small. Like, this is a pretty good design. We may need to use taper bearings or roller bearing or something to prevent it. Okay, let's make this 60 actually. You know what we can do? We can actually enhance this design by getting rid of this for now. Come on, what is happening? And adding one here, one here. This should further help lock everything in place. Perfect. Okay. This is quite a big chunk of block here. How big is this? This is 32 by 32. Let's do a 20 by 20. Alright. Also considering making this one. So that's a little bit more robust. I mean, we could also add fillets to make this slightly better, but it's not necessary, I guess you could say. Okay, let's get rid of this. Let's get rid of... Let's bring back the body one. We should probably add fillets. So it's looking like a fillet of 1.5. Okay, so this teeth is the most meshed. These two right here is the most meshed. So a fillet of 1.5 looks to be fine. That definitely looks to be fine. We can do a... Really doubt. Let's check right here. Yeah, that's fine. Okay. Wait, let's try both sides just to make sure. Yep, that should be fine. Now let's start the painful process of selecting every singular part here. Or is there a way, can I just click this and do... Oh wow, okay, that works. That's great. So you're saying I just literally click every single one of these. Pause, why are these two so high up? That is so weird. Why are these two so high up? Alright, anyways. Why did that happen? Like, seriously. Please work. Please, just two more. Fillet 1.5. Chat, I think it worked. Can we add a fillet here? 0.5. We should add a 0.5 filler here. Change of plans. We shouldn't have filled it there. I don't know why I was thinking that. Okay, let's see if anything, it looks like it shouldn't mesh properly. Okay, so that meshes properly. Right. We can probably go add clearances to everything now, but before that, let's check. Let's make sure we can actually assemble this thing without it breaking everywhere. Let's do a, okay, where's the... Create sketch. .6 maybe? Let me think. 4.6, 4.6, 4.6, not 4.4. Actually, no. We need to do a M3I expression 3.8. Now we can put the heated insert in here. And then 5.5. Let's do 6 since we have a lot of space here. I need to insert this bolt all the way in there. Let's see how many millimeters. 2.8. So we did 4 millimeters. It should be plenty enough. Yeah, everything looks pretty good. There's absolutely 0 bolts here. We need to add some type of like this, and then we can do offset by 2, and then do a this needs to be 20. What is the distance between here and here? This is 36. Alright, and we should probably add some clearances, to be honest. We can do that in a second though. Okay, let's go ahead and do the same for this. Create sketch, project, offset 2, and oh, I'm so stupid. What am I doing? I can literally just do this. We need to do a new body, or else it's gonna join the other one. There we go. Here to here's 18. So we can do like a 7. did it connect? What the heck? What the heck happened here? Okay, let's do create sketch. Project offset to 7.5. Okay, this is good now. Now we can do create sketch, project. Okay, now we have great clearances for absolutely nothing because we're not going to mount anything here. Okay. Let's go here, here. Chamfer. Let's go here, 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 chamfer. Clicked fillet on accident. 3. Looks pretty good. Chamfer 3. Okay, yeah, this looks amazing. Alright. This is the joint completed. That's what it looks like. Maybe this shouldn't be 3. Let's see. Yeah, I think it would be fine actually. Right? We can literally go 3D print this right now. Let's see. Should be able to do a 0.5 fillet here. Exactly 30. This is good. Okay, so I think we're done here. We can go ahead and let me think, what do we do with this one here? We need to have some screw mounts, obviously, still, but let's just do that real quick here. I think it's just that 4 for now. Okay, project this. Let's have one here. 2.8. And one here. this, mirror across this. Now we should be able to extrude everything. Go back. 5.5. Let's go do a 6. 7. No, let's do a 6, and then we can just do. This would look better than the 3D printer not being able to actually do it. Wait, let me think. It'd probably be easier if we just did this. This. Oh wait, I forgot to do this side. Oh no. There you go. Nice. Let's go 6. Okay, nice. And then some heated inserts probably. M3I. M3I. Just this mirror across here. What the heck, man? Okay. Eight should be good. Alright, perfect. Let's put in this. Where did that go? And now we should be able to see 0.2, that's good enough. Okay, perfect. So everything's good. We should go ahead and go 3D print this to see what it looks like. Let me check some more other stuff real quick. This is gonna be a pretty hefty piece of chunk of freaking plastic right here. Oh my gosh, that is a pretty hefty piece. Oh my goodness, okay, I should probably reduce some of the size. We don't need all this, especially for testing purposes. Okay, let me think. How can we reduce the size of this? Okay, to be honest, let's just go like this. Because we don't need the... We're not going to put anything. We're not going to put the aluminum extrusions. This will save a lot of print time and some materials too. Negative 7.5. Okay. Okay, let's add the, let's call this side bottom, side middle, cycloidal top. Don't know how much offset we need, so let's do offset of 0.2 for now. 0.3 maybe? 0.2. Think of 0.2, 0.3. Let's do 2.25. There we go. Actually, let's add a change parameters. Cycloadial. Okay, so cyc out offset 0.3. Okay, did not mean to do that. What am I doing? Create sketch. Pause. I'm going to actually do something different here because what I'm going to do here is go to this and go all the way through. And now I can bring back cycloidal middle. Create sketch. Offset. Cycload. -8. And now when you do a okay, why is that not offsetted? Okay, whatever. Alright, now we can bring back the cycloidal middle and everything should be offsetted properly, hopefully. And now let's get rid of those sketches because it's getting annoying. And offset each one of these middle holes by output offset by 2. This needs to be careful. If this is too big, we're gonna have too much. What's it called? What's that little thing called? Backlash. What is it called? What did I offset? No, it should just be normal offset. Offset. Okay, there we go. We need to change. I don't know why I put 2. It should be 0.2. offset OF, offset OF, offset OF. I think I might have messed up, guys. Why is this 10.4? I'm gonna cry if this is broken. There may be a problem. There may be a problem. Why is that exactly 10.4? I'm very concerned now. It's 8. 10.4. That doesn't make any sense. Why is this 10? Why is that 10? 8 and 10? That's perfect. That means I can add ball bearings to this. Okay, we'll worry about that in the future. So apparently, my settings line up exactly to where this is a good number, where the thing of this is 10. Because I just added a 0.2. That is crazy. Okay, let's go Z. So this is exactly 10? Oh wow, that's amazing. Okay. I'm so cooked. Now I can't go forward. Great. Okay. Go back and select every singular one. That's massive though. That you could like put ball bearings and stuff in the cycloidal disc itself, which will be pretty cool, I guess. Because 10 is the standard size. Okay, so now we have this. Okay, what can we do now? Now let's get rid of this, get rid of this. Bring back the cycloidal middle. And so offset OF. Offset. Should have done this in the beginning. I might start doing that in the future. Actually, the compute through all the everything, like every single of these steps from the beginning might lag, so maybe not. Let's just take a little extra time right now because I had to do 2 instead of 1, but it'll be fine. Really want to get these out of steel. That would be pretty cool. Okay, let's do boom, 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 and then add a chamfer of 1, maybe 0.6. Yeah, it looks pretty good. 0.5. 0.7 maybe? This will make it more dimensionally accurate because of elephant foot and stuff like that. .6. Okay, we should probably do So 0.5, let's just do 0.5. Make sure they're all in phase. We can add a fillet of 1. Extrude this all the way through. Now we know how they all line up. I really hope the 3D printer can print this part. Kind of forgot about that. 0.5. My nozzle's gonna be 0.4. So okay, so it'll be able to print it. I think we can low-key get to printing. I think I added tolerances to everything. Wait, let's make sure we can actually assemble this thing without any problems, because we can't. That would be quite annoying. Okay, so first we will need to mount the motor on, which we need to do. Okay, so the very first part. So this is the first part where we mount the motor to. What we'll use here to... There's a lot of clearance, so it's okay. Here to here is how many distance? 6, so we can use 8mm, that's fine. Once we mount this, we need to put the rods in, and one screw right here. Okay, let's make sure... Yeah, okay, this is good. Everything is good here then. Then we'll mount the ball bearings, and then we can mount... You know what? I actually do not have 3mm rods right now, so I think what I'm going to do actually, extrude this all the way through, and just use should I do that? I'm trying to think. Yeah, let's do that so I can get this made literally today, because if I don't have to go buy other components, don't really feel like doing. And this would, yeah, this is a better idea, because it'll make it, this will ensure that it's very, very secure too. Okay, now the thing we need to worry about is this other side, which is this side right here. Let's worry about this extra. Let's do it both side. Okay, perfect. Wait, what? Why did it not get cut all the way through? Strange. Let's find that we can just go like this. sketch. This will make it more, this will make it stronger too, so it's a good thing. M4, M3I. Okay, what? Why did I not do M3I? Where did all the other... Okay, there we go. M3I. We need to do extrude of -6, I believe. 6. Perfect. And also another thing, almost forgot, we can round these edges. This is A4. Okay. Oh wait, we still need to buy the other components. Oh well. Thought I could get away from it, but looks like I can't. Because we still need to buy 2 ball bearings. But I don't necessarily think we have to have the ball bearing for this to work today. Not sure though, okay. Yeah, let's just get it printing, I guess, for now.